Good day, viewers. Welcome to Fame Global Academy. I am your chemistry instructor, Mr. Michael Osa. All right, very quickly today, we shall be looking at questions as related to UTME, or better still called JAMB examination. UTME examination is quite imminent, it's forthcoming, and so students face challenges in trying to attempt to answer questions as regard JAMB or UTME questions. But today, I'll be showing you fast and simpler ways of answering UTME questions with ease. We have a question on the board that says the most suitable method for separating a mixture of ethanol and water is, I take that again, the most suitable method for separating a mixture of ethanol and water is, we have A there, we have filtration, we have distillation, we have sublimation, we have chromatography. The first thing you should note is this: whenever a question is asked in chemistry, you should be able to figure out the topic where such question is extracted from. And this particular question we have on the board is from the topic known as separation techniques of mixtures. That is the different method adopted or you can adopt to separate different kind of mixtures. And one other thing you should note is this question says the most suitable method for separating a mixture of ethanol and water. What kind of mixture is ethanol and water? Ethanol and water are two liquids that we call two miscible liquid. They are what? They are two miscible liquid. What that simply means is when you mix up ethanol and water, definitely they will mix because they are miscible liquid. And the most suitable method to separate a mixture of ethanol and water is what we call, say, distillation. What is distillation method all about? It's a separation technique used to separate two liquids that can mix together, such as what? A mixture of ethanol and water. And this mixture, the separation method is based on a property known as boiling point. When you mix ethanol and water, both of them will mix. And you can actually separate them because they have a wide difference in boiling point. Ethanol boils at 78 degrees Celsius, while water boils at 100 degrees Celsius. So if you have a mixture involving both of them, you can actually separate them based on a wide difference in their boiling point. So how is this achieved? When you heat up this mixture involving ethanol and water, ethanol has a lower boiling point while water has a higher boiling point. It simply means that at 78 degrees Celsius, ethanol in this mixture must have started boiling, and when that happens, it will distill, that is, leave the mixture, while the water will be left behind. So in that method or in that means, we have successfully separated this mixture. So the best method to separate two liquids that can mix together or that are miscible is by adopting a separation technique called distillation. All right, let's look at this question. The question says, give the IUPAC name of the compound below. Give the IUPAC name of the compound below. This question is extracted from the branch of chemistry called organic chemistry. IUPAC nomenclature of organic compound. The word nomenclature simply means naming. Now, there are rules guiding the naming of organic compounds in chemistry. But we are not going to look at all that. We are just simply going to apply the particular one that is needed to answer this question as we have it on the board. Subsequently, you can subscribe to our YouTube channel, where we'll be having detailed explanation of IUPAC nomenclature of organic compound. The question on the board says, give the IUPAC name of the compound below. Which rule can we apply to answer this question? The rule simply states that in an organic structure, as we have on the board, if we have the presence of a functional group, we will give priority to the functional group. The functional group on the board is the HO, that's the OH functional group. We call it the hydroxyl functional group. And of course, the homologous family that has this functional group is what we call the alkanol homologous family, So we have two functional groups in this structure, one at this end and another at this end. So invariably, we can decide to start numbering our carbon atom from whatever end we choose to do that. The reason being that the first carbon from this end is bearing a functional group HO, while the first carbon, if you want to take it from this end, is equally bearing a functional group OH. So I can decide to start numbering from this end. What's the essence of numbering? We are numbering this carbon atom to locate or get what we call the longest carbon containing chain, which will bear the parent name of this organic compound. So we have carbon atom 1, 2, 3. So this structure has three carbon atoms, and the name for three carbon atoms is prop. We call it prop. And again, what you should be able to find out is this. This prop is the what? Is a member of the alkanol family, prop. Then the next thing you have to do is at carbon atom 1, we have what we call the hydroxy functional group, and at carbon atom 3, we have another hydroxy functional group. So it simply means that we have two hydroxy functional groups. So how do we go about naming this structure? This is 1, 2, 3. You cannot name it as propan. At carbon atom 1, there is a hydroxy group. We now say propan 1. Then at carbon atom 1, 2, 3, there's another hydroxy group. We call it propan 1, 3, because it appeared twice, the hydroxy group at carbon atom 1 and at carbon atom 3. You now make use of the word or the name, the prefix called, say, di. And of course, you apply the functional group name, diol. So the appropriate or correct name of this structure above is what we call propan 1, 3, diol. So the correct option here is option B. I hope you got that. We have a question on the board that says the molecular formula of a compound with an empirical formula CH2O and a molar mass of 180 gram per mole is. Looking at this question critically, you will agree with me that this question was extracted from the topic known as empirical formula and molecular formula. Let's look at the question again. It says the molecular formula of a compound with an empirical formula CH2O and a molar mass of 180 gram per mole is. From this question, the empirical formula has been given. That makes the question a lot more very simple, easy to calculate. Now, what you should be asking yourself is, what is the relationship between empirical formula and molecular formula that will enable you to get the molecular formula of the compound? The relationship between empirical formula and molecular formula is that molecular formula of a compound, we now use empirical formula N is equal to RMN. Empirical formula N is equal to what? ROM. What is ROM? It's a relative molecular mass, but we have on the bulk, I call it say molar mass of the compound. Are you with me? So the empirical formula has already been determined, which is what? CH2O. All you need to apply N here is equal to what? The molar mass is what? 180. The molar mass is what? 180. But look at this question on the board. The elements that make up this compound, they are what? Carbon, hydrogen, and oxygen. You must first of all determine this N before you can go ahead to determine the molecular formula of the compound. So what you should tell yourself is, what is the relative atomic mass of carbon, hydrogen, and oxygen? So it is expected as a chemistry learner that before now you have known or you are familiar with the respective relative atomic mass of every element, at least the first 30 elements as we have them in chemistry. Now, the relative atomic mass of carbon is 12. We now say 12 plus, while the relative atomic mass of hydrogen is 1. Then we have 2 atoms of hydrogen in this compound. Say 1 times 2 plus, then the relative atomic mass of oxygen is 16. Then you close the bracket and you apply this your N, which is what we are looking for. Everything equated to what? 180. Are you following me? We have solve this mathematically. We have 12 plus 1 times 2 is 2 plus 16. Then N is equal to what? 180. 12 plus 2 is 14 plus 16 is 30. 30 times N, we have 30N is equal to what? 180. Now divide both sides by 30 to make N the subject formula. And of course, when you do that, we have 18 divided by 3, we have 6. Then substitute N is equal to 6 into empirical formula. Now the empirical formula is what? CH2O. We now say CH2ON. Where N is 6, we have CH2O. Then you say C multiplied by 6 will give you C6. H2 multiplied by 6 will give you what? 6. Then O multiplied by 6 will give you 6. Whatever value that you have outside the bracket multiplies everything as you have it in the bracket. Of course, we have C6. H2 times 6 is what? 12. Then O6. So the correct answer to this question is option B. C6, H12, O6. Are you following me? These are simple and fast ways of answering JAMB questions. Option D, kinetic energy. One of the challenges that students face as regard JAMB question is this. Whenever they ask you a question related to JAMB, you should be able to determine or know the answer before even going to the options to look for it. Let's look at this question on the board. The question says, what is the term for the minimum amount of energy required for a chemical reaction to occur? The topic that this question is extracted from is what we call rate of chemical reaction. And of course, we are talking about activation energy here. So what is the term for the minimum amount of energy required for a chemical reaction to occur? The correct answer here is what? Activation energy. The big question now is, what is activation energy? Activation energy is simply the minimum amount of energy that reacting particles must possess for a chemical reaction to occur. When do we say that a chemical reaction has occurred? It's only when reactants have successfully been converted to product that we can now say that a chemical reaction has occurred. In other words, for a chemical reaction to occur, what we are saying in essence is that the reacting particles must possess a certain minimum amount of energy before they can be what? They can be successfully converted to product. But in that same reacting system, there is a self-existing opposing energy, which is the activation energy of the what? Of the rate of the reactant of the reaction system. What am I saying in essence? The activation energy is also the energy barrier. Yes, the reactant, they want to possess a particular energy so that they can be converted to what? To product. We are saying that there is a self-existing and opposing what? Energy that want to prevent or hinder that reaction for coming into what? Completion. So the activation energy is also the energy barrier. It's also the what? Energy barrier. And note, for a chemical reaction to occur, you can as well be asked this kind of question, that for a chemical reaction to occur, the reactant's energy that they possess must be equal to or greater than the activation energy of the reacting system. What are we saying in essence? If the reactant's energy, let's assume that A is reacting with B to form C and D, if the reactant's energy is less than the activation energy, which is also the what? Energy barrier, of course, A cannot react with B or combine with B to form C and D. What I want you to note is this: for a chemical reaction to occur, the energy possessed by the reacting particles must be equal to, or better still, greater than the activation energy of the reacting system. If the reactant's energy is less than the activation energy, which is also the energy barrier, then that chemical reaction is impossible. I hope you are following me. So let's look at another question here. All right, let's look at this question. The question says, what are the separation techniques involved in obtaining pure alum from powdered mixture of alum and sand? And of course, it's quite very simple that you understand that the topic that this is extracted from is what we call separation techniques of mixtures. But what kind of mixture do we have here? Now we are having a mixture of alum and sand. So it simply means, when they are telling us that the what? That the alum is in the powdered form, so it has been grounded into fine powder, while the sand still remains the way it is, and both of them have been mixed. Now, they are mixtures because they are two what? They are two different substances that have been what? Joined together. That is, they have been mixed. But what we are saying is, because they are mixtures, we must adopt, or there are some method we can adopt to separate their mixture. So what they are saying is, if you have fine alum, that is alum that has been grinded into fine powder, and you mix it up with sand, how do you separate it? What method of separation technique is the best method to separate this mixture? This is very quite simple. Now this is alum already in the fine form, and this is sand. When you mix both of them together, the first thing you do is add water to the mixture. That is what we call, say, dissolution. When you add water to this mixture, the alum, which is in the fine form, is soluble. It will dissolve in the water. It is what? It is soluble, and because of that, it will dissolve in water. But sand is what? Sand is insoluble. Insoluble in water. But fine alum is what? Soluble. So immediately you add water, the fine powdered alum will dissolve in the water that you have what? That you have added, but the sand will not dissolve. It will remain in that manner. All you need to do is to get what we call a filter paper. Just get a filter paper and carry out another process called, say, filtration. This one is dissolution, and it's achieved by what? Addition of water, or addition of water. And when that happens, this soluble fine alum will dissolve in the water, while the sand will not dissolve, because sand is what? Insoluble in water. When you get a filter paper, then the mixture, the entirety of the mixture that you have added water, pour it on top of this filter paper. What will happen is this: the water will now pass through alongside the what? Alongside the fine alum. And this is what we call filtrate. We call it filtrate. the liquid portion from a filtration process. Why the sand, which is insoluble sand, will remain on top of the filter paper. And of course, this solid part is what we call residue. Of course, you can be asked this kind of question too in an exam condition. So the best method you can adopt is, first of all, carry out dissolution, that is, add water to the mixture. The fine alum, which is soluble, it dissolves, so it will dissolve in water, but the sand will remain insoluble. Then get a filter paper, pour the entirety of the mixture on top of the filter, at the top of the filter paper. Now, the alum that has dissolved will now pass through the pores of the filter paper and come out alongside the water, while your insoluble sand will remain at the top. But this powdered alum, because it has been mixed with sand, so some particles, impurities, are being associated with it. So to get purer crystals of this alum, that's why you finally carry out what we call crystallization. This method, as the name implied, is used to get or obtain what we call, say, pure crystals, or samples of compound, So the best method to be adopted to separate a mixture of fine powdered alum and sand is what we call, first of all, carry out the process called dissolution by adding water to the mixture. Then, of course, get a filter paper and carry out a process called filtration. Now, the fine powdered alum will pass through the pores of the filter paper alongside the water, because the fine alum has successfully dissolved in the water. But because sand is insoluble, the sand cannot pass through the pores of the filter paper, and as such, the sand will remain on top of the filter paper. What I'm drawing your attention is the liquid portion that passes through the filter paper is what we call the filtrate, while the solid part that remains at the top of the filter paper is what we call the residue. And of course, to get a purer sample of the alum, what do? You now carry out a simple process called crystallization, which enables us to achieve pure samples of substances as we have on the board. All right, that's how we answer such questions. All right, we have yet another question on the board. The question says, which of the following element has the highest electronegativity? Has the what? Highest electronegativity. All right, this question is just from the topic called the periodic table. And under the periodic table, under a subtopic called properties of elements in the periodic table. And one of the properties of elements in the periodic table, as related to this question, is what we call electronegativity. Is what we call what? Electronegativity. Simply put, what is electronegativity? This is simply the process whereby elements attract electrons to themselves and form negative ions. This is the process whereby what? Elements do what? Attract electrons to themselves and form negative ions. You will agree with me, as studied under the topic periodic table and the properties of elements, that electronegativity does what? Increases from left to right, across the period. Across the what? Across the period. Let's assume that this is a sketch of the periodic table. It simply means as we are moving from left to right, what will be happening? Electronegativity will be what? Will be increasing. Electronegativity will be increasing. And of course, group 7 elements like fluorine, group 7 elements, it simply means that group 7 elements have the what? They have the highest electronegative value, highest electronegative value, electronegative value. That is, they have the highest tendency to accept electrons from other elements to attain stability. We haven't said that electronegativity increases from left to right across the period. Electronegativity decreases down the group. Electronegativity decreases down the group. So let's go and let's select our correct option now from the question. It says, which of the following elements has the highest electronegativity? We have in sodium. Invariably, it can't be sodium because sodium is in group 1. Sodium is in what? Sodium is in group 1, or is a group 1 element. And we have said electronegativity increases from left to right across the period. So it simply means sodium has the least electronegative value. Then we have option B, fluorine. Where is fluorine located? Fluorine is in group 7, or fluorine is a group 7 element, and of course, group 7 elements have the highest electronegative value, and as such, fluorine is the correct option or answer here. Why? Because fluorine is a group 7 element. They have the highest potential or tendency to accept electrons from other elements to form or to attain stability. So that's how you actually achieve that. The question on the board says, which of the following gases can be collected over water? Now, not all gases can be collected over water. The big question is, which type of gas or gases should be or are collected over water, and what are the type of gases that shouldn't be collected over water? The question says, which of the following gases can be collected over water? The answer should be a particular gas that is not highly soluble in water. That is a particular gas that will not readily dissolve in water should be the answer of this question that says, which of the following gases can be collected over water? If you are highly soluble in water, or if a particular gas is highly soluble in water, then of course it shouldn't be collected over water. We have hydrogen chloride gas. This hydrogen chloride gas is highly soluble in water. Highly soluble in water. What does it mean? It dissolves so much in water. And as such, you want to produce a particular gas called hydrogen chloride gas, and you are collecting it over water. So it simply means the entirety of it will dissolve in the water, and your aim of actually producing that gas wouldn't be achieved, or you'll be having extremely difficulty in trying to what? To dry that water that is associated to the gas. So we equally have ammonia. Ammonia is another gas that is what? Say highly soluble in water. Highly what? Soluble in water. And as such, ammonia should not be collected over water at the point of production. Are you with me? Then we have CO2. Then we have Cl2. Chlorine is another gas that is soluble in water. It's quite soluble in water, but its solubility is not as high of that of ammonia and hydrogen chloride gas, but it is equally what? Very soluble in water. And of course, we have carbon dioxide. Carbon dioxide is slightly soluble in water, slightly soluble in water. And as such, the correct answer to this question is CO2, carbon dioxide. This one is readily soluble in water. So what I'm saying in essence is this: any gas that is highly soluble in water or dissolves very well in water shouldn't be collected over water. So you are going to undergo an intense process to what? To actually dry that water that is associated to that particular gas. That made our correct option here to be option C. Which of the following produces effervescence with sodium hydrogen carbonate? Which of the following produces effervescence with sodium hydrogen carbonate? What this question is telling us is, among these options, what will react with sodium hydrogen carbonate to release or evolve a particular gas, and of course, evolution of release of gases when a chemical reaction occurs is what we call effervescence. So we want to know the effervescent gas that will be released or that will be given off when one of these options react with this sodium hydrogen carbonate. Now, another challenge that students have is this: their inability to understand or write the correct chemical formula of the compound sodium hydrogen carbonate. Sodium hydrogen carbonate simply means sodium hydrogen triosocarbonate 4. Sodium hydrogen carbonate simply means sodium hydrogen triosocarbonate 4. Anytime you hear the word carbonate, they are talking about this triosocarbonate, CO3. So it simply means which of these will react with sodium hydrogen triosocarbonate 4 to produce effervescence, that is, that will release or emit a particular gas. And of course, as studied under acid, we were told that acid can react with a compound of sodium or potassium of triosocarbonate to release a particular gas called carbon 4 oxide. Let's look at the equation of reaction. We have NaHCO3 reacting with ethanoic acid. The chemical formula for ethanoic acid is CH3COOH. When both of them react, what happens? You will see that what will be formed is sodium ethanoate. Sodium ethanoate will be formed. Sodium ethanoate alongside water and alongside CO2. Anytime a compound as this that carries or is bearing the triosocarbonate 4, which is CO3, the effervescence that is always emitted or released from the reaction between this compound and whatever compound that is reacting with is always carbon 4 oxide. And this carbon 4 oxide is the effervescence. What is effervescence? The emission or the evolution or the release of a particular gas in the course of a chemical reaction. So what we are saying in essence is any compound that is acidic has the capacity to react with a compound that is carrying any triosocarbonate compound, and if such reaction occurs, there is always the release or the giving off of an effervescence, which is a gas, and that gas is what? Always carbon 4 oxide. So the correct option to this question is ethanoic acid reacting with sodium hydrogen triosocarbonate 4, bringing about the production of sodium ethanoate, bringing about the formation of what? Sodium ethanoate, carbon 4 oxide, and of course, water. I hope you actually had a nice time with us today. You do well to like, share, and subscribe to our YouTube channel. We're looking forward to more exciting class later. But very quickly, today we'll be able to handle some questions as related to JAMB UTME examination. And I believe very vividly that I've been able to stress on each of the questions that was handled today, trying to show you how came about those choice of answer that we actually choose with respect to each of those questions that we answered today. Like I said, always have it at the back of your mind that whenever a question is asked that has to do with JAMB question or in chemistry generally, you should be able to determine or know the topic that particular question was extracted from. And that will go a long way to help you answer that question. Looking forward to see you again some other time.